Okay, now let's proceed to see if we can construct this S versus T graph. Hopefully you've been able to do that. But unless you see what to do, it's going to be kind of mysterious. So, well, let's just get one point on our S versus T graph. First place, let's assume that our X scales are identical, so that this point on this scale is the same X as this point directly below on this scale. And if the points aren't the same, well, we find a point with the same X coordinate, but let's assume that we have the same scale on these two X-axes. Let's find the value of S corresponding to this value of X. Okay, well, that value of S corresponds to the length of this line, doesn't it? Because the length of this line is going to be the coordinate of S, because the line goes from X equals 0 up to the graph. And on this graph, we can do the same thing. Okay, now I'm going to kind of put little tracks on this line here to distinguish it from this one, although it's clear which one is which, but we're going to do something similar for a number of different X values, but let's just get one. Okay, so now here's our value of S, here's our value of T. How can we get a point on this graph? Well, we just take this segment over here, lay it on its side, and that gives us this. Okay, so I can kind of draw that down here. This green segment here with the tracks on it is the same as this segment. And of course I could do this with a compass or with other graphical construction tools. And then I take this one, which doesn't have any tracks on it, so it's just a line of this length, and I'll put it here on the S axis. And I know that this S number here, the S quantity depicted by this length, goes with the T quantity depicted by this length, so I can join these 2 points. And there's, I did not join the 2 points, but I can locate the point on the graph with this S coordinate and this T coordinate. So right there is a point on the graph of S versus T. Now, what is the graph of S versus T? It consists of all points within a certain domain, all points S that match points T, okay? All the ST points that relate whatever this quantity is to that quantity. I'm saying that badly, so I'll give up. Okay, so over here, let's do it again. Okay, now we use this X value. Of course, I'm using a different color so we can see. Okay, so now we have a T value, and I'll use tracks on the T value, and an S value that I can use to construct a new point. Okay, now I have to go a little below this value here, but let's say that this is our segment, same length as this one, and this segment here will be the same length as this one. And now I can project over and project up, and I've got another point on the graph. Okay, I can do, you should have the idea by now, but let me find another good color. Where'd it go? There it is. Okay, we can do another point. Let's go ahead and do a point somewhere in between here. Let's do this point. So right here's our S value, and right here is our T value. So that make tracks in the T value, keep our S value where it is. So our T value is going to be kind of about like maybe here, and our S value maybe about here. And there we have another point on the graph. So we're starting to get an idea of the trend of this graph. Now we'd want to do a whole lot of points if we wanted a really accurate graph and if we were confident in the accuracy of these graphs, but that could be helpful in answering some of the questions on the capstone project. And in any case, even if you don't know, even if you're looking at this as an independent video, whatever the capstone project is, this is a technique for constructing a graph of S versus T, of one thing versus another, given the first thing versus a third quantity, and the second thing versus a third quantity.